Hey everybody, welcome back to chemistry. If I can blow up the slide. So it reads as follows. A 13.53 gram sample of molybdenum oxide, which has a formula of MO2O3, is converted completely to another molybdenum oxide by adding oxygen. The new oxide has a mass of 16.24 grams. Add subscripts to correctly identify the empirical formula of the new oxide. And then you're given some molar masses. Okay, so if I can reduce the slide. Okay, so let's sort of write out an outline for this problem. What kind of information they give you and where we're trying to go. So we have a particular compound of molybdenums called molybdenum oxide, and its formula is MO2O3. And you're told to start with you have 13.53 grams of this. Now, you're also told that oxygen was added to this compound. And we're going to create a new compound of molybdenum oxide. But the problem is it's probably going to have a different formula than this one. So let me give you some examples of the new formula it could be. So for example, it could be MoO2, or it could be MoO3, or MO2O, or MO3O5. So what you have to do is you have to figure out which of these formulas it is. And so I can sort of generalize this by saying we're trying to find what the new compound of molybdenum oxide is. And so we'll call X the number of atoms of molybdenum, and then we'll call Y the number of atoms of oxygen. But we are told what the total mass of this is. It's 16.24 grams. Okay, so we have to figure out which of these formulas here it is. And so what you might remember is the way you figure out that formula is through a technique where you take the masses of the elements in the compound and then work out what the formula is, which is called the empirical formula. So you can see there's a bit of a problem here though, in that we are not told in this problem in the new compound what the masses of molybdenum and oxygen are. Instead, all we're told is the total mass of this compound. So the question is there some way we can sort of infer maybe one of the masses of these elements here, molybdenum or oxygen, in this compound? And there actually is a way. What I want you to notice here is that the starting compound has a mass of 13.53. So you can calculate of this 13.53 grams of total compound, what is the mass of molybdenum? And one thing I want you to notice is the chemical change that occurs is not changing the mass of molybdenum. All you're doing is adding oxygen to the compound, so you're getting more oxygen. But the mass of molybdenum in MO2O3, which you can calculate, that will be retained as the same mass of molybdenum in this new compound. So you can work out what the mass of molybdenum is. So what I'm going to do first is figure out the grams of molybdenum. And then once I figure that out, that will be the same grams of molybdenum in this compound. And then what I can do is I can take the total mass here and subtract from it the mass of molybdenum, and that will give me the mass of oxygen. And then once I know the mass of molybdenum and mass of oxygen, then I can go ahead and figure out what the empirical formula is. So let me go ahead and try that. So the first step again is to take the mass of the starting compound, molybdenum oxide, we have 13.53 grams, and then figure out of this total mass here, what mass is that of molybdenum. So I'm going to go ahead and do that right now. So this isn't so bad to figure out. And so you have 13.53 grams of molybdenum oxide, MO2O3 here. And so the first step is to get this into moles. And so we do have a molar mass of molybdenum oxide. And the molar mass there is going to be, looks like 239.90 grams per mole, so 239.90 grams. Okay, So you can see that the grams of molybdenum oxide cancels out. We're now at moles of molybdenum oxide. So next thing you want to do is you look at this formula here, and you can see that for any molecule of molybdenum oxide, you have 2 atoms of molybdenum. Another way you can say this is that for every 1 mole of this molybdenum oxide, you have 2 moles of molybdenum atoms. So I'm going to set that up here in this equation. So we have 1 mole of molybdenum oxide over 2 mole of molybdenum. And so now at this point, we're now at moles molybdenum. And so now what we can do is get that in the grams molybdenum. And you have to look up the molar mass of molybdenum in the periodic table. And it's 95.95 grams over 1 mole of molybdenum. So I worked this out earlier, and what I got was 10.8287 grams of molybdenum. That should be enough significant figures. Okay, so we know here that in this compound, this was the total mass, and so we know that 10.82 grams of it was molybdenum. And so that means in this new compound, because all we're doing is adding oxygen and nothing else, you still have 10.82 grams of molybdenum. So what you can do at this point is with a new compound, you can take the total mass and subtract the mass of molybdenum. That should give you the mass of oxygen. So again, what I'm going to do is I'm going to take 16.24 grams total in this new compound. I'll write that here, MOXOY. And we're going to subtract the mass of molybdenum. And this should give us the mass of the oxygen. And so what I got when I figured this out earlier was I got 5.42 grams of oxygen. Okay, so now at this point we have a mass of molybdenum for this compound. We have a mass of oxygen in this compound. So from those masses, what you can do is you can figure out the empirical formula for the compound. So I'm going to go ahead and do that. So we have molybdenum and we have oxygen. So let me write down molybdenum's mass. It's going to be 10.82 grams of molybdenum, and we have oxygen's mass, 5.42 grams of oxygen. So when you're working on empirical formula, you probably know that the first step is you have to take these masses of these elements and get them in the moles. So I'm going to go ahead and do that. So 1 mole molybdenum over the molar mass of molybdenum, which is 95.95 grams of molybdenum. Do the same thing with oxygen. So you're going to divide it by the molar mass, which is 15.999 grams of oxygen. So when you work these numbers out, what I got was 0.112797, that's enough sig figs, mole of molybdenum. And then for oxygen, I got 0.33877 moles of oxygen. So I think you know at this point, you have to divide by the smallest number, like this. And so when I do that, I get 1 mole of molybdenum, and when I divide these two numbers, I got 3.003 mole of oxygen. And so what you can see is 3.003 is very close to 3. And so we can just assume that for every 1 mole of molybdenum, we have 3 moles of oxygen in this compound. We can convert that to atoms. For every 1 atom of molybdenum, you have 3 atoms of oxygen. And so the formula should be MO, 1 atom of molybdenum, O3, 3 atoms of oxygen. And so that's it. Okay, thank you for listening. We'll see you next time.